Welcome to another episode. Today we'll be looking at another project titled Prediction Using Unsupervised Learning. This is it's also a beginner project, and we're going to just dive right into it. As you can see, it's under the Sparks Foundation, the Growth March 2022 internship, and this is my name and the project title. So let's just dive straight into it. So I decided to use the Jupyter Python. I use Python language, the Jupyter platform. As you can see, I began with first importing the necessary libraries, the NumPy, Pandas, Matplotlib, Scalan. Basically, all these they are used in the project. So this is a project prediction using unsupervised learning. And the first thing, of course, after the libraries, is the dataset. You have to have the dataset which you are given. As you can see, I downloaded it. It's the IRIS, the most famous and common dataset used by beginners. Yeah, so you read the data from the given dataset. You can basically use the link. You can paste here the link, but I decided to download it and just use it manually. So you can see while I output the data, this is the output. You can see it's the ID, sepal length, centimeter, sepal width, petal length, petal width, the species. So basically this means it's both numerical and text data, so you cannot work with both of them at the same time. So you have to sort out the information and use the uniform. So I sorted out my information as required. So basically it's like removing this, the column, the species column, and then working with the numerical aspect. And to continue on, we shape the data, just define it. The name of the dataset dot shape, and then maybe the information to understand more of your data, the data you're dealing with. The null, if there's any null value, you can see none null, float 64. Yeah, basically you get detailed information by shaping the data and the information. After that, you see, okay, the output, it gives the number of the rows, which is 150, and 4 columns. So you can see 1, 2, 3, 4, what we're dealing with. Then after that, what does it mean to do unsupervised learning? So unsupervised learning, basically, you don't use any forms of like the naming aspect. It's just like random. There's no specific aspect on how you're coming into this data, or using small forms of like datasets. Sorry. So for this bit, I decided to use the most common way was the k-means classification. So we find the number of clusters for k-means classification, meaning we're going to use the k-means method using unsupervised learning, where there is random formation and random picking of the data sets and training them and predicting them, rather than just taking data and grouping it into sets. That's what I mean by unsupervised. So in this state, find the optimum number of clusters. As you can see, what I have done, it's basically a bit for someone who has not done this, you cannot understand it well enough, but I tried to make it as simple as possible, whereby you define the x values, because we have 4 columns, so I had to state this on 3 values. The data set ILOC will be from 0 to 3. Then you say the for loop for I in range 1 and 11 characters, and the k-means. Yeah, and cluster is equal to I, meeting contains plus plus. Actually, this means I'm using this for loop so that we can grasp the whole of the data and not omit or use small data. So after that, I plot the results onto a line graph, which is the elbow method. It's also a method used in k-means. As you can see, actually there was an error, which I basically didn't want to change it because it says k-means is known to have a memory leak. So, and that is what we're using. So I had to work with it the way it was. This is the output. After that, so you can tell the graph is it's beginning with a sharp, and it's reducing the number of clusters. So it means as it begins, the WCFF is high. As you progress on, the number of clusters reduces, making it more accurate. So applying, or therefore we apply the key, the data set. You apply and then you predict. This is when you predict your data after it is done. Then you visualize the clusters on the first two columns, and you basically do the scatter plot. Then I plot them, the centers of the clusters. So as you can see, they represent the data, the species of the data. And go back so you can see the IV set also after prediction and k-means algorithm is used. You can see how they form in the iris virginica, then the iris vesicana. So you can see the centroids here. They're not that much further apart. Yeah, so that's the end of my video today.